Are you ready?
Yes.
Hello. Okay, so hello everyone. Thank you so much for joining us today for our Moon Day celebration today on July 20th. And we are joined today by NeuroSpace's own founder, Irene. So you can maybe provide a little introduction on yourself.
So yes, I'm Irene. I'm the founder of NeuroSpace. We have founded the company in 2023. I have prepared a short presentation for today's event. So welcome. It's very wonderful having you here. It is a great event. We have set up so many things. I want to show you all in a short presentation soon.
Yeah, great. So we'll move right on to Irene's presentation.
Okay, so yes, today is the International Moon Day. So what we do is having a huge event to celebrate the day. So what is happening or what happened? The Apollo mission was landing on the moon at the 20th of July, and it's been such a great anniversary, so we are going to re-celebrate it. And due to this, we as NeuroSpace, we have these fancy looking moon rovers, and we offer students from all over the world to participate today and drive our rovers online. And therefore, we want to thank the Moon Village Association for giving us this opportunity, because yes, it's a great idea to celebrate this day. And then we also have someone else. It is the spaceport Rostock. They have hashtag TheMoon. It's a beautiful moon yacht. I can show you some of the images. And it's been also presented by the Planetary Transporting Systems. So we will hear more about them in further presentations. I will just go on. Just about us, as told, we were founded 2020 in Berlin, in Germany, and we are a group of engineers. We can do designing, manufacturing, testing, all types of space hardware. We have many experience, launched several steps to space, so some of us was already participating in several missions. And Moon was something new for us, so we decided to take part here. So our idea was to create a rover which is more open than what's been offered currently. And so we have, yes, invented hiveR. And I would like to talk more about our system now. So let's start about our vision. So what we wanted to do is having and creating something which is open, flexible, modular. So it just was, the idea behind it was like something which relied on the CubeSat technology, which is like, yes, created new space basically with a standardized open source system. And what we also wanted to do is, what we think the best approach is, instead of creating big, heavy rovers with multiple systems on it, create rather small ones which are modular, but also capable of swarm technology, so that there you have rather a fleet of rovers instead of just one big one. So at the same time, you can perform several experiments, collect samples at the same time, and I think this is a good approach. So yes, of course, we always get the question, why the moon? And of course, it is a gateway. It is our closest neighbor, and we can reach it within a few days in best case. And to set up a moon base makes sense, because from here you can start to everywhere else. Get there much easier, and of course it makes sense because it has all these resources on it, and we can mine it, we can maybe even grab the water, make a fueling system out of it, and reach any other goals quite easily. So like to talk about our rover, which we named HiveR. So there is Hive already included, and it's a very cool looking rover, which is very small in dimensions. So it has a CubeSat on the top, but this CubeSat is more or less the payload. So um, what why it's been done this way? It's very easy. Um, we were just experimenting a lot and figured out people and everyone just needs to have a platform, a robotic platform. And this is even more sufficient than like a whole ready-made rover. So flexibility counts, modularity counts. And so we went through all these challenging process creating moon rovers. Um, so how to make it out of a complex system something which is standardized and which is open for markets, and something which does not consume too much time and money, of course, because creating something for the lunar surface is extremely costly. So um, why is it like this? It is because of the lunar environment. So we have, of course, it has all these good things. As mentioned, it's the Earth's nearest neighbor. We can create a moon base and so on. But it also has all these very complicated things. So something which makes the whole mission very complicated. It is, for example, that it does not have any magnetic fields, no protection of radiation. Temperature impact is really high. You don't have any atmosphere, and this is also something which creates another problem, and that's the regolith. So you have this very fine moon dust, which is so sharpened it can intrude into your systems, and so on. So facing all these problems had then lead us to our HiveR solution. So what we said was, of course, we have to reduce the cost. It should not be that expensive anymore. We have to create a standard, so kind of blueprint construction for constructions, and of course, it has to be done very fast and easy. The first step we went was taking, of course, the CubeSat, because CubeSat has so many type of payload system already been developed. You have all these systems running like onboard computer, EPS, and so yes, so it made sense to reuse that system. So we decided to take a CubeSat and build a chassis around it and make it moon-proof, like the CubeSat approach, but for the moon. But this is not enough, as we have figured out. So we have to make a business out of it, lower down the cost massively, and also diversify our product. So yeah, I think the best thing was if you just not only focus on the moon. So we created HiveR, and HiveR is a tiered system. It's a tiered solution. We said, of course, we are anyway developing a rover for the moon, but on its way there, we figured out we anyway hit all other applications as well. So our rover, which is capable of all these extreme environments, can easily be used for Earth application as well. So that's why we said we will develop the same rover, but for much lower cost. For example, educational purpose, for developing purpose. So you don't have to spend too much money for the real system, but you can have the simple version of it, which acts the same, which does not have all these qualified materials, and therefore you get it for an affordable price. And so you can also get it in different tiers. So we have this more massively created version for industry, but also for civil service. So there is the qualification level, and therefore the components are much valued. So it costs a bit more, but you know that everything exists in all these tiers and they act the same. And so what do we offer? We offer a hardware solution. It's a platform which is open. So it's not that everything is locked up from our side. So you can even change the wheels if you want to. If you have a sensor, you can mount it on our system and yes, add it for your purpose. You can even use your own onboard computer, and or if you want to, you can use a Raspberry Pi. So that's also something which we went on, like why not creating an open software solution? So you can design our hiver and add it to your payload or your mission even by using open source software, for example, ROS, Robot Operating System or software. So it is an open platform, and on the other hand, we also offer you, so everything you created for hiver, you can also offer through our hiver platform and make a business out of it. Yeah, the benefit is whatever you create, it's not only focused for the moon, you can also use it for Earth purposes, and I think here the possibilities are much higher, and it definitely makes sense. So that's what we say. Yeah, we already have these things. We have developed all the rovers there. The tier 1 is ready for production. You can order it if you want to and start developing your or realizing your own mission. And for today, of course, I also want to say you can try it out. So we offered it for student groups all over the world. And so they are already starting. And this is where we are today. We are not in Berlin, we are in Rostock. And Rostock is in the north of Germany, near the Baltic Sea. And it's an airport, so maybe it gets a bit noisy because here the Eurofighters are also starting from this airport once in a while. And so, yes, we do have this test field offered by the PTS and the airport provider. So it has this dimension, as you can see, it's quite big, like 5 meters to 70 by 17, and it is full of regolith, and it's very fine grain, so it comes quite close to the moon. We already had tested our rover several times, and yes, we have realized what an impact this has on our rovers. So, but this time they actually work quite fine, and so yes, the students can test it out. They have several possibilities to test our rovers through the field. There is also an exhibition running outside of the field, and we have lots of presenters today. And these are the hiver bots. So up to now, we mostly presented the one with a different. We have this different chassis approach, the drive system. So we have the rocker, which mostly was presented up to now, but now we have also our own created version of it. So it has 4 identical drive systems, which has this double wishbone suspension loaded with a spring, a torsional spring. So yeah, you can figure out how it works. Actually, it has already run a field test on a volcano in Sicily and performed very well. And today it's up to the students. They can try it out. So what the students will use is our hiver platform. It's yes, software which we have created, and you can enter it with a simple browser. You can monitor what's going on from view of our rover, and then you have these commands. You can use your keyboards, you can use the mouse and just push the buttons. You can just enter some predefined instruction tools if you want to, and we have also created some mission. It has some speed controls, and also in case you can use the gimbal of our camera system. Yeah, I think it's very much fun, and we had even kids running it, and it's very easy to use. So yes, the current rover, one of them. So it's been already running, and I hope it will be a wonderful day today. And so yeah, it's happy to join this event, and thank you very much also for the Moon Village Association to letting us being part of it, to Spaceport Rostock, to #TheMoon, and the Planetary Transportation System. So yeah, have a wonderful day today. So we are just running still. So we will have some more presentation running the next few minutes. What will be the next one? I think you are.
I think that's fine.
So then it will be Frank from.
Yeah.
So it will
So
be
we will
Frank.
be. Yeah. Thank you so much, Irene, for the wonderful presentation. We will now be welcoming our next speaker. So yeah, thank you.
Okay, great. Have fun.
Yeah. Okay. So this is our wonderful next speaker. So I'll let you introduce yourself.
Yeah, hi, I'm Frank, Chief Moon Operator at the Spaceport Rostock, and we actually operate Europe's largest fully privately financed lunar test facility. And when you know, or when you're wondering what a Chief Moon Operator is doing the whole day, well, it operates the moon. Sounds pretty cool at the end. It's also a lot of cleaning, as you will see later on. Because the moon actually is extremely dirty. And when you will drive later on a rover, if you're lucky and secured your slot there, you will find out yourself that it's really, really dirty. But that's also the fun and the challenge from the moon, where actually the astronauts, when you go to YouTube or search for old videos, you see they have these wonderful white suits, and as soon as they step onto the moon, they become dirty and gray. Good, but so much for the introduction, for the dirt, and for the beginning. And then...
Yeah, so we can move right into your presentation, which I will now be sharing, and yeah, you can just kind of flick through it.
Perfect. So, welcome to the moon. Actually, when we think about the moon is pretty far away, right? Normally, it takes quite a while, depending how fast your spaceship is. So you might travel 3 to 7 days, and you have to travel 348,000 kilometers in average, right? It varies depending on the time in the year where you're trying to reach the moon. And you need a pretty powerful rocket and a huge budget, a huge travel budget. And if you look up, there are actually only 12 reviews at TripAdvisor. So many people haven't been there. Very weird, because everybody sees it, right? If you go out in the night and you are lucky, you might see the moon. And actually, that's pretty cool for myself. You see where you're working on every night. Well, not every, but most of the nights you see some glints of the moon, and that's really, really nice. But actually today we are at the moon, and we haven't traveled so far and not so long, because all you need is a short trip to Rostock-Lage, which is actually our airport. So it's a short trip from Berlin or Hamburg by car. It's located at the Baltic Sea, pretty close to the city of Rostock. And most people here in North Germany probably haven't visited Rostock, but Warnemünde, which is the beach of Rostock, and some people actually know Karl's for strawberries, but see people laughing here in the audience, so it's well known. But when you go there to either the strawberries or the beach, you actually pass Rostock-Lage, and it's worth to leave the motorway and take a short trip, like 3 kilometers from the motorway. We have Rostock-Lage, and there's our spaceport. Spaceport Rostock is actually located in the public airport. That means when you book your holiday flight from Rostock, you can actually check in your flight And then before you go to security, you can go to our moon location. And I will show in a few minutes the pictures of that moon location. Now, for scientists or customers who would love to test their experiments at the moon, that location is quite convenient because you can either drive your experiments and your equipment to Earth, you can even fly to us. So when you're from the southern part of Europe, for example, or from Australia, from the US, it is a very large public airport. So all you need is whatever, book a cargo flight, put everything in, and then you can land directly, more or less, in the moon, right? It's just 5 meters from the runway. So no further travel needed, just fly to us and we can install your equipment directly in our lunar test facility. And if you have very large stuff, you can use the harbor of Rostock, which is Germany's largest Baltic harbor. But in this case, give us a ring up front, because that means you have a very, very large equipment and we would have to check if it actually fits into our environment. So why actually did we use the airport? I'm a huge fan of public science. And when you do an experiment, I think, especially if it's tax money financed, that the people should actually see what you're doing. And this is more or less an aerial view of our airport. You see the classical cargo buildings and other buildings, but we selected specifically the public terminal of the airport. This large building with the blue rectangle around it. And that means regular people just walk into the building, looking for the check-in, looking for the travel agencies, and then they might wonder what this interesting installation is. And that actually is our lunar test facility, TheMoon. And this is more or less how it looks like. On the right side, you see our facility. And if you wonder, yes, this is how the moon looks like. It's gray. It's dusty. It's really broken, small broken stones, very, very thin stones. It's more like floor. It's not sand, it's really stones. It's very, very sharp. You can use it for your morning peeling if you like, but afterwards you might look a little bit gray. So it's, you should put up some other powder to get you a nice look like. But beside that facility, which is mainly interesting for scientists, we also have a small exhibition with our lunar lander, constructed by PTS, and actually the mock-up we show here would allow the transport of 2 rovers to the moon, and more or less this is also the reason why we have it here. We are working on these moon landers, we are working on rovers, and to test them under lunar conditions, we needed that facility. This facility is roughly 18 meters long and 5 meters wide, so it's a very large field. And if you switch on later, not now, later to the stream with the rovers, you will see how the rovers drive over this very large test field. If you do it now, you would miss my presentation, so stay better here. And this facility then is mainly for rover tests, but not necessarily only. We also have companies who want to test their ground experiments for the moon. They needed this specific soil, these called regolith, the moon dust, to test if they can do seismic measurements